go ahead and introduce our next speaker. That's me, Dominic Halsmer, engineering professor at Oral Roberts University. And my talk is on extending the Affordance Structure Matrix to account for history, purpose, and ingenuity in the reverse engineering of natural systems. And I'm pleased to work with some undergraduate engineering students at Oral Roberts University. One of them is Mackenzie Edwards. As long as we're going to talk about the Affordance Structure Matrix, I'm just going to throw one of those out at you right here in the first slide, which is from this paper on affordance-based housing preferences. It's actually, affordances are being used in a lot of different fields right now. And one of them is, how do you decide what is the best kinds of features in a home or house? And so what you do is, in an affordance structure matrix for any system, like a house, you list the components of that system across the top, and you can see here the different aspects or rooms or elements of a house. And then each of these elements plays a role as it combines with other elements, often in relationships, to provide certain capabilities or potential actions that you can take because of the existence of this system. And here you see listed down the left-hand side several of these features or actions that you can take, things like sleeping, cooking, eating, things that you would that are afforded, you could say, by the features of a house. And so you fill in the affordance structure matrix as you come to understand how each of these elements contributes to each of these affordances. And affordances can actually be positive or negative, depending on your point of view or the value or weighting function that you place on it. So that's a possibility too. So we're going to get into more of this affordance structure matrix in a little bit, but that's just an initial look. If you're interested in this topic in more detail, you can see my book, Hacking the Cosmos, How Reverse Engineering Uncovers Organization, Ingenuity, and the Care of a Maker, which came out a couple of years ago. And I use this in my engineering courses here at ORU to orient the students in our engineering program to the science and faith conversation and the role of engineers in this conversation. And so we look at affordance-based reverse engineering, how it can be applied both to artificial and to natural systems to understand these systems better. And it was Jonathan Maier at Clemson University, an engineering researcher, who first introduced this affordance structure matrix as a graphical tool. So we'll look further into that, and then how we might extend that to gain insight into history, purpose, and ingenuity when we're reverse engineering natural systems. Of course, you probably already all know what reverse engineering is, but let me just tell you a quick story because it's a fun little story. When the end of World War II, a couple of B-29 superfortresses went down off the Aleutian Islands into Siberia, and the Russians grabbed those and never gave them back. You know what they did? They took them apart piece by piece and reverse engineered their own B-29 superfortress, but they called it the Tu-4 Bear bomber. They were good at reverse engineering back in those days. And in fact, they were so good that their version of the B-29, the engines tended to overheat and catch fire, just like the American version. Donald Norman was one of the first ones to come up with this usefulness of the idea of affordances in engineering. In his book, The Design of Everyday Things, he says an affordance is a relationship between the properties of an object and the capabilities of an agent that determine just how the object could possibly be used. And he also says affordances provide strong clues to the operation of things. And this refers to how useful affordances can be in reverse engineering if you can recognize the relationships, the important relationships in systems that you're doing a reverse engineering project on. As I mentioned before, Jonathan Maier at Clemson was the one to write the book on this about 10 years ago called Affordance-Based Design, Theoretical Foundations, Practical Applications. And he proposes that the concept of affordance, what a system provides to an end user, or he extended this idea to be just between two parts of a system. If you have a relationship between any two parts of a system that ultimately contribute to an end user affordance, then that's also an affordance, but he calls that a part-to-part or artifact-to-artifact affordance. And this concept is an underlying and unifying principle in the science of product design and reverse engineering, he claims. And when I look at the universe, and I understand as an engineer, that's what engineers do. They create affordances. If you look at a smartphone, you see tons of affordances, that is, potential actions you can take because of all of the layers of relationships embedded in that technology. And those are nested affordances. So when you look at something like a smartphone, you see all of these affordances that have been created by an engineer or a team of engineers. And when you look at the universe, that's again what you see. You see relationships that lead to potential actions or capabilities of agents. And so it's a reasonable hypothesis then to suggest that the universe is actually an engineered system. Here's an example of another example of an affordance structure matrix for a robotic vacuum cleaner. Here you see, I apologize for this fuzziness on this slide, but basically you just have listed across the top are the elements of this robotic vacuum cleaner. And here you see listed on the left are the positive artifact user affordances, that's AUA, things like maneuverability, aesthetics, but then you might have negative artifact to user affordances like electric shock or noise would be things that would be not desirable. And then you have artifact to artifact affordances that result from all of these relationships. Things like the ability to reach various surfaces, suction capability would be positive part-to-part affordances. But negative may be clogging, or maybe it consumes a lot of power that you would rather not have it do. And so those are negative affordances. And as a design engineer, in the forward engineering process, you would try to maximize the positive number of affordances and minimize the number of negative affordances. My student, Maisie Edwards, put together this affordance structure matrix for an electric shaver, and you can see across the top the elements of that shaver. And then one thing that's illustrated in this one is in some additional feature where you have a weighting function for how well each of these, how important each of these affordances is, and then a numerical system in the matrix, which gives a measure of how well each of these things contributes to that particular affordance. So you have a way of quantifying, trying to at least to quantify how well they provide these affordances. But where did this idea of affordances come from? And this is where it starts to get interesting, I think, with regard to natural systems, because it was in the field of ecological psychology and James Gibson who first started to work with this idea of affordances. Gibson said that the affordances of the environment are what it offers the animal or agent or human being, what it provides or furnishes either for good or for ill. If you look at this picture closely, you can see that this deer is afforded camouflage by the relationship it has with its environment. Gibson and his wife, Eleanor Gibson, who was also an ecological psychologist, claim that these affordances are directly perceived by the agents and by humans, and that they kind of invite us into exploring more about the universe and about our environments. You begin to ask yourself, especially engineers, I don't know if you've ever heard an engineer use the term, well, what do we make of this? In other words, what are all of these relationships good for, and what can we use them for? What do we possibly do with them that would bring value and enhance life? In a rich landscape of affordances, Reitveld and Kiverstein say, affordances are possibilities for action that the environment offers to a form of life. And an ecological niche is a network of interrelated affordances available in a particular form of life on the basis of the abilities manifested in its practices. Affordances, then, are relations between aspects of a material environment and abilities available in a form of life. So this begins to illustrate the ecological niche, and we're going to get into what it means to perform niche construction and how that's related to evolutionary paradigm. So then if a niche is the function or purpose of a species within an ecological community, including the environment to which it has become adapted, as well as the role as producer and consumer of food resources, Rob Withigan writes that the concept of affordance might also help to clarify the process of niche construction. What this process actually consists in at a behavioral level is the perception, utilization, destruction, and creation of affordances. He goes on, indeed, in constructing a niche, animals perceive and utilize affordances, and by so doing, create and destroy other action potentials. So they're changing the set of affordances as they go through their niche construction activities. Hence, an affordance analysis can not only help in clarifying how the niche is constructed, it also helps in understanding what the modification of the niche consists in. Indeed, animals bring about changes in the affordance layout, and this modified layout is passed on to the offspring. And in the extension of the Affordance Structure Matrix, I'm hoping to be able to capture this kind of niche construction activity. Just recently in 2020, Manuel Harris Escribano, in his paper, The Evolutionary Role of Affordances, Ecological Psychology, Niche Construction, and Natural Selection, writes that two allegedly competing views for explaining the evolutionary role of affordances. The first is based on natural selection. The second, though, is based on niche construction. According to the first, the affordances are resources that exert selection pressure. The second view claims that affordances are ecological inheritances in the organism's niche that are the product of a previous alteration to the environment. I argue in this paper that the views are not competing, but rather complementary. And this is Harris Escribano speaking. In this sense, affordances play the role of either resources or ecological inheritances, depending on the temporal stage of the evolutionary process. Again, Withigan et al. In the paper Affordances Can Invite Behavior says affordances are not mere action potentials, but they can also invite behavior, and also they can be normative. And the strength of this invitation depends on three things: capabilities of the agent, importance for survival and thriving, and cultural conditioning. Actually, four things, and also personal history and experience. And this is an interesting idea because here's where I think you get some rich interaction with theology and metaphysics, because it seems to me that God has engineered this universe with the affordances that it has in such a way as to invite us into a deeper understanding of his existence and into a relationship with him. So agency is the capacity to modulate the coupling strength with the environment. The agent can influence to what extent he or she is influenced by the different invitations that affordances elicit. By modulating the coupling strength, the agent simply alters the dynamics of the animal environment interactions and thus the behavior that emerges. And again, I see a strong connection here with a Christian worldview, in the sense that as God invites us into this closer relationship with him through what we experience in nature, we can make choices, and those choices will tend to either enforce that relationship and strengthen that relationship, or if we make poor choices, then it will tend to decouple that relationship. Here's my last example that I've been working on for an affordance structure matrix with a new twist to it. And if you look at, anybody know about beavers, you know that they are engaged in niche construction in a very interesting way, because they have certain features, things like teeth, very strong teeth and jaws, tail and legs, that they can do things with given the environment that they're in. They typically find themselves around a stream where there's trees, but there's also predators. And so, for example, one thing they can do, here's an affordance, they can swim. They use their tail and their legs and they can swim in the stream. They can chop down trees with their strong jaws, and they use their teeth and chop down trees, and they can drag those trees to wherever they want, and they can use their teeth and legs to drag those trees into the stream. And they can warn against predators by using their tail. You ever seen how they slap their tail on the water to warn other beavers that there's a predator around? But the interesting thing that occurs here is as they drag those trees into the stream, right? And by the way, if you don't know what the definition of ingenuity is, it's skill or cleverness in devising or combining. And that's what we see, things combined in interesting ways. And not only beavers exhibit this kind of inventiveness, but are maker in creating all of these elements to these systems. The interesting thing is that then these beavers are able to build. And by dragging enough of these trees and shrubs into the environment, into the stream, they can construct a dam. And you might think that that's a bad thing because they cause a flood. But actually, in terms of many of the species that exist in that area, in these areas, a wetland is preferred. And so that pond that results allows beavers at least to feed, because then they can build a lodge, and they have a foliage like cattails and lily pads and things that grow in these wetlands. And they're able to parent then and feed their young with these additional food sources. And they have protection from the predators in the lodge. So this is where you see new elements of the system arising because of the action of the agent, whereas originally the system was limited in the elements across the top here. The Affordance Structure Matrix is now extended in this way to include additional elements that have been either constructed or have arisen because of the constructive and niche construction efforts of the beavers. And then these new affordances result and are passed along to the offspring. This is really illustrated well in the book that just came out a couple of years ago, Eager, The Surprising Secret Life of Beavers and Why They Matter by Ben Goldfarb, an award-winning book that came out recently. He says in this book, he talks about how we've lost a lot of our habitats and beavers because of development and hunting. He says the consequences of losing beavers was profound. Streams eroded, wetlands dried up, and species, from salmon to swans, lost vital habitat. Ecosystems without beavers ecosystems with beavers are far healthier for humans and non-humans alike than those ecosystems without beavers. And I saw some interesting parallels with the book by Marcus Mueller, Resonances, Neurobiology, Evolution and Theology, Evolutionary Niche Construction and Ecological Brain, The Ecological Brain and Relational Narrative Theology is this book. And he says here that the theory of niche construction widens the understanding of evolution by recognizing the feedback between organisms and the environment. Given this move, evolutionary biology now has to work with two kinds of inheritance systems, a genetic one and a cultural one. The theological expectations and demands as to what natural science can say about natural change cannot be completely satisfied by neo-Darwinism, he claims, but they can be satisfied via an extended theory of evolution and niche construction. Niche construction provides a fruitful key metaphor for understanding the relationship of the triune God to the world. The triune God can be modeled as the ultimate niche constructor because life and environment are identical to each other in God's relational narrative essence. From the perspective of creation, God can be seen as the ultimate or eschatological environment for his creatures. All creatural niche construction is actually niche reception, as it is a gift of the Creator. So those are just some closing thoughts on how this relates to a Christian worldview. Paul, you have a question?
Yeah, I have a question. Well, just the word affordances really threw me in this context, because it seems to me that it has nothing to do with economic value, which is like affordability, which is an important engineering parameter, but I would just think of it as features. You're talking about features.
Well, they define it very carefully in the field of ecological psychology, and it's actually a relationship between the environment and the agent that's within that environment. And now engineering researchers have gone on to extend that definition to include relationships between parts of a system that ultimately lead to something that an agent can do in an environment. So there's end user affordances, which are just relationships. Like you're sitting in a chair right now. That chair, because of your relationship to the chair, it affords sittability. So that's an affordance.
That sounds like nominalism.
Nominalism?
Yeah.
What do you mean by that?
Well, people sleep because they have a dormitive power.
I think this is somewhat related to the idea that, are you talking about like the Thomistic idea of things having powers created?
Well, it's just a name for something without really explaining what it is. I don't know. Maybe I'm being too critical, but I'm just thinking of, does it have a purpose-based assumption?
No, that's what science and faith researchers have noticed, is that it doesn't carry any teleological commitment with it. You could say, for example, that a brain is for thinking, and we would, as Christians, we would think, yeah, the brain is for thinking. That's what it's for. But here you're talking teleology. But in terms of affordances, because you have a brain, you can think. It's simply a statement of what you can do. Then that carries with it no teleological commitment, right?
Like capabilities?
Yeah, it's similar to just capabilities.
Or like the software engineers say, that's not a bug, it's a feature.
Well, I noticed that you tied it in with evolutionary niches, ecological niches, and I was wondering if with this, there are a lot of evangelical Christians or conservative Christians that don't believe in evolution, and wondered if this idea of affordances might, because you tied it in with evolution, and if this could sell people on evolution. You did tie it in with evolution, particularly on ecological niches and natural selection. And
I certainly, as an undergraduate and engineering professor who also teaches general science classes, I certainly like to bring evolution into the conversation and encourage students to dig into that concept and see what they think about it. So I think it's a natural way to just bring it into the conversation, and I'm glad to do that. Bill Jordan, I see you got your hand up.
Now, I appreciate your willingness to keep pursuing this topic. This is about the third time I think you've expanded what affordances really mean. The first couple of times I'm not sure I understood it. I think I'm beginning to understand it a little bit more. I would ask if you could send slides to those of us who would like it, because you have some new references I haven't seen before I'd like to follow up on.
Yeah, be happy to do that. Kurt Wood, you got your hand up?
Yeah, it seems like there's a lot of resonance this year. It's really interesting to hear about this. I think it's the first time I've heard about it. I have a son who actually studied design at Stanford. I'm going to want to talk to him about this now and what he's learned about this from his coursework and stuff.
Yeah, more and more engineers are looking at affordance-based design. If you remember, I said maximizing the number of positive affordances and minimizing the number of negative affordances.
it seems to me that, yeah, sort of from a theological point of view, if you bring it into sort of human ecology space, then this really seems to resonate with this whole, with this whole idea of a creation mandate. This whole Psalm 8 kind of, what is humanity here to do? What is God's role with that? And then and this whole idea of providence. What is God's how is it that God provides for the creation, and for us as his agents in creation. And then you sort of factor into that, sort of these, even some of the ways that, and things like inherited wealth, inherited, everything. I mean, these are sort of consequences of even many generations back, choices that were made.
Right.
And another, just back on the ecology thing, and another thing I'm reading this book, The Overstory, which is kind of a dark dystopian ecological novel, I guess you might say, but it's talking, about forests and how they work. And as a native Californian, I mean, I'm, just understanding how a redwood forest basically creates its own microclimate, over a period of, I don't know, centuries,
Right.
or something like that.
Yeah.
And this is just another example, I guess, of what you're talking about.
Yeah, I think you're right. I think it's certainly related to the argument from providence. It's related to the providence of God, and we see how specifically that providence is played out in terms of affordances. Derek, you got your hand up, I see.
Yeah, just real quick question. You mentioned at one point that affordances can be normative. I mean, you can take things and use them for good or evil. Sometimes it's not always clear just because you can use something, how it ought to be used. But have you read anything about how people are beginning, or whether people are claiming that they can discern normativity? I believe you can, but any ways that you can discern the normativity of an affordance, I guess is the question.
I read that in one paper, and I've forgotten now who the author was. I have to go back in my PowerPoint slides to see that. But I was kind of raised my eyebrows when I read that.
Mm-hmm.
But they were claiming that there's affordances can be seen as not just positive or negative in terms of some measure of value, but they also can be seen in a social context as correct or incorrect, or right or wrong behaviors. And so I was kind of, that just immediately got me thinking about the religious theological implications, but I don't remember the specifics on that. I'd have to go back and look at that particular paper.
The possibility to do things and the oughtness of doing things, whether you ought to do things or not as well, that's a fascinating idea that you can discern that. But
and when you look at life and the fact that life is good, and if you just keep that in mind as your kind of value, your value that you're looking at in terms of right or wrong or good or bad, then here you begin to see choices or actions that humans take are certainly correct or incorrect when it comes to life.
And there seems to be consequences built in to creation. If you use an affordance to do something you ought not to do, then eventually it comes back to bite you, right?
Right.
Pollution or whatever.
Built in or engineered into the system.
Yes. Yeah. Thank you.
Sure. Michael Everest.
Yeah. Hey, thanks, Dom. Great talk. I don't think this may be my first time in kind of an engineering session at ASA. So really interesting to hear what you're talking about. I have a question kind of on the engineering theory end, kind of more your introduction than the ecology part. I'm wondering if in the theory of design, if how you would handle a user who finds an amazing application of something that wasn't designed for that purpose. How would that fit in if, for example, if you tried to reverse engineer it, or where would that fall on it wasn't afforded by the device. But look, here all the users are doing it, and maybe that's what it becomes known as.
Using a book as a doorstop, you mean?
Sure. But it was originally intended for something else, but now the best doorstops are all books.
So serendipity is just something that kind of comes along and surprises us sometimes. But those are, I think, exceptions to the rule, and you might get tripped up in a reverse engineering project as you come across something like that, which doesn't seem to follow. But in general, I think you're going to find. I like to think in terms of reverse engineering as opposed to the forward engineering process. So if I was doing a reverse engineering process, in general, you're going to find that the affordances that are in existence reflect what the device was intended to do.
Great. Thank you.
Sure. Kurt, you got another question?
Yeah, it was just another thought, just because I'm wondering if this kind of framework would be another way to kind of address some of the creation care kind of topics, especially with some conservatives where I just continue to be mystified. I'm not where they are.
Yeah.
Maybe politically or something, but it just seems to me that if you're a true conservative, then the concepts of sustainability, this idea that we don't want to hurt future generations.
Right. Well, you probably noticed that in the very last, second to the last slide with the beavers. By not facilitating beavers in our environment, we're doing ourselves harm overall. And I think the same kind of thing could be shown with affordances when it comes to things like climate change too.
Right. Yeah.
All right. Well, thanks a lot, everybody. I had a fun time.